I replaced the category kFace with kFace data because that would do as well. kFace data is a new thing, a struct containing the k-axis and a corner index, which means that corner index must be defined first. And the corner index is a kFace rank n, 0, which you can define if you for declare that, and then define this, and then define the kFace rank using corner index. I hope, because now this is then calling something on the class that is being defined. And that normally works. I mean, maybe I have to split this up, kFace rank, into a base class and this class. I'm gonna get rid of this. Just let's remove use math corner index. Missing template argument. Yeah. Corner index is not depending on n. Yeah, there's one missing as well. Well, that wasn't too bad. To when or where can I define kFace data? Hopefully as early as possible, maybe even already here. So that's going. This is going to be the base class of kFace, by the way, but then initializable by initialization list, passing an access type, k-axis, and a corner index. So that might not work yet, I think, because corner index is a kFace rank which wasn't defined yet, so the size is not known here. I'll have to try it, I guess. Tempted to call it CI, which I used everywhere else, except here, of course. Well, I used it in the hyperblock. Corner index usually called CI for some reason. I don't like abbreviations, but you talk to AIs, they come with abbreviations and they copy that and then they stick and shit. Now I have an abbreviation. Yeah, as long as they are super local, like CornerIndex CI, and then that's the CornerIndex in this little block of code. That's not too confusing, I guess. It might be different. I mean, these are kind of local variables, but to use that for a struct member, I mean, that's something you have to be able to jump to. You see CI and you go, oh, what is that? And then you put a cursor on it, I want to jump to it, and it's just too short. Yeah, it's not good. But yeah, if normally you call it CI, and now I don't want abbreviation, I'll have to call it CornerIndex. That is, I don't think I ever used CornerIndex. Something else than CI. Yeah, here. But okay, I'm kind of working on that. Here it's called C. It's a test. I'll call it corner in a comment. Oh, here it is called corner. A corner, that is. You have to make the stuff like that consistent. I like the name A corner here because we just construct a face ID from one of its corners. CornerIndex is less clear than saying, you know, this is just one of the corners, so A corner. By index, because well, you see the type. It's not really much reason to call it CornerIndex, I think. I'll keep this, I think. In comments, I really often leave out the index. I see. I just call it a corner, and then, yeah, I mean, abstractly it is a corner, even though the type then is the CornerIndex. I mean, how else are you going to refer to it? Well then, a corner, because also in this case it's just one of the corners of the kFace. 0 corner maybe. How to say this? It's not A, so I want to make it specifically the corner that has all those zeros there. Right, well, lots of time into the comment. I don't think it will compile because kFaceRank is not defined yet. And this probably needs it to be defined. or that error. That even comes first, yeah. Oh, it does compile. Shocking. Maybe because, yeah, it just does compile until you instantiate a template. I'm not using kFace at all yet, so it's not instantiated. But let's instantiate it then, and then it should fail. Or so at some point now I'm using I think a passing an access type and a corner index to a function. Here, this one. So instead of doing that, I want to pass in kFace data. I also want to pass an initializer list, possibly, over a k-axis and a corner. Therefore, we take a kFace data by value. So you can just construct it from an initializer list. However, I also want to pass a kFace derived from kFace data. So I make it a const reference. Const references are allowed to point to temporary. So if I would pass an initializer list to this, it will just construct a kFace data, and then we'll have to const reference to that. But we can also pass something that is derived from the kFace data. And then of course I have to replace this. This is now kFace dot k-axis, and this is this corner as the kFace dot 0 corner. Yeah, near the k-axis again. Yeah, I can hardly believe it still will compile. Unfortunately, it actually doesn't. Error, no matching function for call to. It actually does compile. It just the call to the constructor doesn't compile anymore. So we could now do it like that, passing an initializer list. It doesn't work. Passing math CornerIndex 7. Okay, const math kFace70 as this argument discards qualifier. Where does a const come from? I mean, there's no const here. Did I define my CornerIndex as const? Nah. kFace rank, kFace data, const reference, tools. Oh, here, yeah. Maybe here anyway. In call to unsigned integer do type math kFace rank and k remove bits. This removes bits from doesn't remove anything. It just gets it, so it should be const. Can be const. Is it requires before or after the const? Oh yeah, that a few days ago. Oh, I think it was after. Yes. Well, amazingly. Yeah, and then at some point I want to define a class that is derived from the kFace data, and that should allow me to convert between the kFace and the kFace rank, I think. No, not kFace rank. kFaceIndex. That is not defined yet. This is a factor index. Why is that called kFace rank? Actually, it is the rank. Should not have been called a rank, I think. It should have been called kFaceIndex. It's like literally an index. Derived from vector index. Yeah, nou ja. Yeah, I think that is better name. Then you get stuff like CornerIndex is kFaceIndex with k equals 0. That makes so much more sense. Man, I'm sleepy. kFaceIndex. So I want to be able to construct the kFaceIndex from kFace data and, well, no, just from kFace data. This can also be changed, can it not? Do we even need this still? Yeah, anyway, no, I don't want to use an access type here, that is always be ridiculous. Let's just use the CornerIndex. Keep doing that. The CornerIndex used to be just 32-bit wide. It didn't have to be concerned about the dimension. Vertical structure. Yeah, I don't think this is what I want here. Problem is, yes, in this call here to the deadline. Yeah, it's an access type POD. Right, yeah. Hi Thomas. But I can explain. What is it that you don't get? Yeah, my current problem is that the corner index is almost a specialization of the kFaceIndex, namely only the kFaceIndex or k equals 0. So I'm trying to construct a kFace here with k equals 0. And I can hardly reason. I can't reason about this. I really have to just feel it, as it were. I have a bunch of x's, these x's, and I want to. I want to see them as an. How did AI call that? A coordinate mask. So each bit is 0 or 1, which then isn't even a real coordinate. It's just the index over that. Stupid music is voicing it again. Yeah. First I have to wrap my head around if this is the correct type to use. I mean, we start with a binary something that just tells me which axis is being used. Oh, which, yeah, it's vague, man. It's very vague. Here's another way to point at axis. I just have all the axes set. In fact, this is like the corner at 1, 1, 1, 1, 1, all ones, and then this is one of the other corners, isn't it? Because I'm really trying to create a corner here. Maybe I should use a vector type instead of. Yeah, Thomas, that's the right place. You are at the right place. CornerIndex. Yeah, on the other hand, what I just did would simplify it. I mean, I think this was already jumping through hoops because I was allowing to create a corner, basically a kFaceIndex from an axis type if k equals 0, meaning that, and then is it a corner. So in the special case that the kFaceIndex is a corner index, I would allow it to be constructed from an access type, which I also pulled from my head. And then in order to be to convert this binary thing, which is the most human readable thing to, you know, say which access you want to use, I think, would be to go through the POD type. But now I approach it from the other side, namely from the definition of the kFaceIndex itself. And it doesn't work anymore, but I suddenly realize that it probably does work if I just pass this directly. And yeah, I think that when I wrote that line that I just deleted, that was jumping through a hoop to get it to compile. But if now this compiles, that would be so much better, wouldn't it? Yeah, this feels good. I think this is the way. And I shouldn't call it C1. I call my corner indexes CI. Let's call this one CI1, and then, or do I even have a C2? There's no C2. Maybe it was a typo to begin with. This should be oops, CI for corner index. Okay, now we have an instantiation of a standard array math kFaceIndex. Blah 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 blah. K equals 3. So that the k minus 1 is not a problem. Required from here. Could not convert brace enclosed initializer list to a math kFaceIndex 72. Oh yeah, that's, yeah, okay, that's I get that one. I just deleted the default constructor except for corners. That's not a bad thing, because this is just nonsense. This should return an array. So the array of kFaceIndexes of a k that is one less than the current object. How do we construct those things? So the current kFaceIndex has this as mask. And this is the rank. These are the fixed coordinates, and then we have to unpack them. K-axis unrank RR. And the other one, you can also unpack that. So the other one becomes a corner index. Let's see if we can do that. Corner index. And that would be an unpack of FFF. How do we do that? That is the opposite of this. That would be utils. Deposit bits. Which takes a value and a mask. The value then is FFF, and the mask is what we just created there. Let me see. So the RR and the FFF refer to the comment that I have somewhere. All the way up here. But they are not good names, I think. Especially not now the comment is so much further away from that code. Here I call them rank bits. Rank bits and fixed bits. They are better names, I think. Choose rank bits. Fixed bits. But then again, they're not really bits. Let me see. This is an int32. Well, that's, yeah, deposit bits text set. So yeah, the CornerIndex has a constructor that is explicitly taking a size type. Yet I can construct it from an unsigned int32, so it's not that explicit, if you get what I mean. Jesus, explicit for k equals 0, that makes it a CornerIndex. And then we want a size type. Well, that's okay, apparently. At least I didn't compile it yet, but I'm going to assume that this compiles. And now I have a combination again of k-axis and a CornerIndex, and I made it a new type. That is, oh, I called it axis, that is wrong. Axis. There's no such thing as a k-axis. Unless k is 1. But never mind that. So instead of a separate pair like that and that, let's just construct a kFace data. But that, on the other hand, I had planned to make this a base class of something called kFace. You know, for nobody wants to talk about the data really. That was just temporary thing. Until we can define the kFace type. And the reason I can't define that here is because that is going to have an interface that needs kFaceIndex to exist. Hello, Joker. So I'm gonna be stubborn and put it here anyway. Make that a class, and then hopefully at some point it won't compile because kFaceIndex is not defined fully yet at this point. So that is kFace is derived from kFace data. It doesn't have any other fields. but it should have a constructor, of course. Public constructor. And I might use the same trick. Allow at the very least to be constructed from a kFace data const reference. But yeah, maybe also from the two separate things. I mean, so if I don't know. If I do this and I want to construct it from a k-axis and a 0 corner, then I can just pass it with braces around it, and then it will construct that. Joke how to learn C++. Oh, you could watch my streams for 10 years and then pick up something. Or you can start coding yourself, and then maybe in 1 or 2 years you can code C++. I don't know. Have a look at still the same error, I hope. Ooh, that looks different. In instantiation, required from here, no matching function for call to deposit bits. Oh, I'm trying to pass an access type there. Why is that not working? Access type is an template. Is not the problem that there is can't deduce a type? Because the access type is something else than it's a bit set. Sorry, yeah, no, never mind that. You can't pass a bit set. An access type is a bit set. I want to have the underlying mask of the bit set here. So I would say the problem is in this line. Bit set, bit set, bit set. How do we get from a bit set to the underlying mask? So I want a mask type. A mask type is returned by nothing. Oh, yeah, just operator parentheses. Now what? Okay, so now we have a mask type instead of just the bit set. And then it still can't do it because it requires unsigned integral. Apparently my mask type is not an unsigned. Oh, it's an unsigned char. Yeah, I had that before. So I want to be able to pass whatever I want here, including an unsigned char. It should just deduce the t from the first argument, not the second one. Well, if I can help it anyway. That ain't easy. Is that possible? is possible. Yeah, of course it is possible. But you're not going to like it. Where the hell is deposit? It's a bit dubious though. I mean, I could say the type is determined by the value. Mask. What if you pass two unsigned integral types that have different size? What does that mean? I think that just means that you are lazy. And the smallest one is the actual one. And then the rest should be zeros. It should be zeros in the one that is larger. Great mask is const expression. Okay, let's do something really difficult. Going to allow this, as in call it T1 and then another one, T2. So we allow them to be different. And then we're going to return the smallest one. But yeah, what is that? I don't know. So we're gonna do auto. And then I need result to be that smallest type. Yeah, here I have to decide what type that is then. So using result type is something. And then this is a result type, and that must then be the smallest of the two. That should work. So how do we select the smallest type? Some type traits thing. Oh, I can spend 10 minutes of finding that in the in the documentation or the C++ reference. I mean, but you can also ask an AI. Right? They know that kind of thing. Why is this so bright? Yeah, this one. Oh, there can't be a static assert. Just stop. Stop before it tells me I'm an idiot. Did I change the wrong one? Or just the other one that has the same problem? This is about depth. Okay, deposit. And here we had it about deposit. Deposit. Confusing. Oh, it's inside that function. Ah, no, of course. And no, it doesn't do it. So this does work if I cast it to a size type, but that is very unsatisfactory. I'm just gonna remove the explicit here. Is that not safe? Right, so now we have this and this, and yeah, I don't know. Actually, let's see, I changed my mind. I should not remove the explicit. I should. Where's the thing? Yeah, I should fix the type, of course. Can still stay explicit, I think. But the type that I use here should be something else than the size type. That should be the type that is actually being used for the bit set, which is something. And then here I probably should cast it. What is that type? Yeah, there's this type. I can get it from access type, or I can just repeat it. Conversion from unsigned char to non-scalar type. Math a corner index requested. So it still doesn't work. Now we have two types, this one and that one, and the smallest of them is an unsigned char, which is then therefore returned by deposit bits, and that exact same type should be used as the explicit constructor argument for CornerIndex. So the question is, which type is wrong? Yeah, I see an unsigned char. I'm pretty sure unsigned char is correct because, well, n is just super small, isn't it? N is like 7. Let's print that here. Yeah, n is 7. So that does fit in an unsigned char. So yeah, why not? And then I'm happy to have it managed that the deposit bits accepts two different types and still returns a smaller type. And then it says, but you can't do that. Construct something from an unsigned char. Well, why not? Because I just made it work. Well, no, I didn't make work. I just tried to make that work. As in, this is a kFaceIndex, and kFaceIndex now has the constructor. Provided that k equals 0 of an unsigned int with at least 7 bits, which is an unsigned char. It should totally be using this. How the hell would that not compile? I think we have to split the problem into two sub-problems. First we isolate a line, so a lot of white space. This is the problem. And then I split up the... So I think I have an unsigned char here. And then I try to assign that to the CI. And it's indeed, it says error conversion from unsigned char to non-scalar type math CornerIndex 7 aka math kFaceIndex 7,0 requested. Why is that a problem? Now my idea was that we had a constructor of unsigned char, so maybe it's not the case. If that's not the case, then well, let's just add one. That would be really weird, but okay. So in my opinion, this here is an unsigned char. Now, if this is not an unsigned char, then this is going to compile, maybe even completely. And if this is an unsigned char, as I hope it would be, or should be, then this is going to say, hey, you can't do that. You can't have the same constructor twice. Cannot be overloaded with. I think this means that we already had it. Okay, so apparently this is already an unsigned char, but to be sure, can comment that out. Now I'm knowing for 100% sure that there's an unsigned char here. And then see if we still get the same error. Yep. I think the explicit here refuses to use the assignment constructor, or what is it called? Copy assignment. Because I learned something new. Or I knew that in the past and I forgot it, and now I learned it again. And still, I learned something new. So I still have to remove the explicit then. But. I don't want to. I think this works. Just go away. So they just have to construct it and construct it. That should work. And it doesn't. Oh yeah, now we get the expected error at the end. This is just really weird. Can't do it. Can't use an assignment there. No, okay, so we have this, and now I want to combine those two into one, namely we have a kFace in comma k. Why is the thing not highlighted? No, it is kFace. There's my kFace, and that takes a kFace data. Oh, that's probably going to be problematic. So I want this to be constructed from axis and the corner. That is, it takes an kFace data, which says the axis first. Okay. So really, you want to pass an initializer list to construct the kFace data, and then from the kFace data we construct the kFace. So this should compile. Hello, Cotarino and Anonymous. I think, yeah, we can still get that error. So we did get past that last change. And now we want to pass these things directly. And you're going to tell me that the explicit is going to be in the way of passing this. Oh, wait a minute. No, I can't do that. I need to pass the k-axis here as well, which is this thing. Oh shit. You think I still remember that? Nope, just not there. I don't think it is. Actually it is. There it is. Just axis type. it's just printing problem. Well, not just the printing problem, but that one is flooding so much, it's demanding attention. You can't print a kFace yet. Let's fix that then. Where are my other print-ons? Oh, they are not here, right? That's the only one. Well, I'm just gonna put it here then. Oh, ish. Yeah, I have to print the data. Okay, access. Okay, access. 0 corner. 0 corner. You gotta be effing kidding me. What is it with templates and base class access? What is this? Required from. There are no matching function of call to math. There are 3 candidates. Where's my data? Here, data. Okay, this should be the one. No known conversion from argument 1 of the enclosed brace enclosed initializer list to kFace data what? It's completely interpreting wrong. Why is it interpreting it wrong? What? These are the moments where you just don't understand it and then think, well, let's just add 2 braces. I don't know. Maybe it works. Maybe it helps. Probably doesn't, but it's the exact same error. Now we just keep trying stuff, remove braces until the error makes sense. Exact same error. I think it's full of shit, you know that. I think it's just the problem is the explicit. So I'm trying to construct from an initializer list. How else can I interpret this? So that would be constructing an kFace data from an initializer list. An initializer list contains an access type and something that can be converted to a corner index. But the corner index refuses that argument because the corner index is an kFaceIndex with k equals 0, which has a constructor that would work if there wasn't an explicit. I'm totally going to remove the explicit. Yeah, now we're back on track, and explicit is out of the door because I got tired of it. It's probably going to bite me at some point, but well. Now what? Where are we? Okay, so we have a kFaceIndex, that is the current object. And that was I don't like it that the return type is a line higher, really, because it's, I see this and then I think, oh, it's a constructor, because it doesn't have a return type. But no, it's not. Okay, so I converted the kFaceIndex to a kFace. And then we're going to generate all the facets. How do we do that? Let's first make a result. This is my result. Yeah, the default constructor doesn't exist. Is that impossible? Maybe it is impossible. I think I need a default constructor. Okay, let's add one. So the default constructor for the kFaceIndex, and now k might be 1, so that then is also the default constructor of a corner. which we then override. I think the whole thing is just going to be filled with undefined. I don't really want that though. I just would like it to be uninitialized. So I have a default constructor that only works for k equals 0, and then, well, I have to remove this, I think. But if k is larger than 0, then I'm not super interested in initializing the base class. Unfortunately, I think the base class has a default constructor which always initializes itself, which kind of makes sense, I suppose. Yeah. Nothing we can do about it, short of using dirty casts. Actually thinking about using the dirty casts now. Yeah, it can't be helped. No, decoration matches. What did I change then? Cannot remember. I edited something though. Visit indexes. Yeah. This. Oh, so yeah, never mind then. I didn't know that. You have to add it here as well. Absolutely no difference in the output. It's like we didn't make any progress whatsoever in the last 2 hours. Still the same output. Okay, and the problem is that this be deleted. Yeah, okay, no, it should not be deleted. Okay, now to fill the array. something did change. I'm printing kFace now. This is new. Yeah, well, nobody will know if that is correct, although I recognize this, I think. It's slightly annoying that it uses 8 bits, I mean. Well, we have a 7 cube. Yeah, happens there as well. Four. Well, I have to run over all the k-axis, which means we have to run over all bits in k-axis, which means we have to run over axis, which is a bit set, which is not that big. Axis, k-axis. I think this runs over all the bits, so let's test that by printing what the hell it is. Yep. So we run over all the bits by mask. And then we want to assign in order, I guess. A facet, which is a kFaceIndex and k-1, which we can construct from, I don't need to print that, we can construct that from I think a kFace data. Yep, that's what we have to do. So this must be constructed from Well, let's call it a facet. Yeah, what is the facet? Well, I don't know. So maybe kface knows. kface.facet. Probably have to pass it the axis though, and the coordinate. The coordinate of that axis. Yeah, then I might as well have that return a kFaceIndex. Mine k, 1, k minus 1. So let's move that as well. Where the kface is. Do I have defined that yet? No, wait a minute. I need to define the facet now inside kface. And that takes an int and a bit set, which is equal to access type. Yeah. No, wait a minute. The thing was going to return a kface n, k minus 1. And it takes an access type. I don't think it knows that access type is again as usual. Just have to. If you define that in a base class, then why is it not available in the derived class? Stupid, man. That's what I mean. It just doesn't know what it is. Ridiculous. Can also not do it like this. Maybe I should do it like that, like yeah. Use put that in front of it here. Nope, still doesn't know what access type is. The using is not enough. Access type, I mean. Compile. Undefined reference to the thing that I just added, but did not define. Yeah, let's do none instead of any. Not none. Axis must be a single bit, and if I end it with k-axis, then it should not end up being none. Okay, that bit must be set. AKA axis must be a single axis that is set in k-axis. Okay, we're going to reconstruct this thing. kFace with k1 less. Which is again only constructible from a kFace data, which we construct consistently from an initializer list. And the initializer list contains axis minus the axis that we are passing here. So there would be an, I don't know, does bitset have something fancy for that? I don't think so. What can we do with bitsets? Reset reset bitset. Hey, it totally works. Yeah, so I could do this, but well, why not just call reset? Let's see. Well, reset actually changes it then. So look at that again. Reset. Reset. Yeah, it's a non-const function. So in that case, I do need an result access. Access. Yeah. Set the access. And then I have to also reset this bit. But now I have to just set it, actually. I have to set it to either 0 or 1. To this, and then set, and then nobody knows. And then we return that thing. Wait a minute. X-axis? No. Still reconstruct the kFace from the data, so like that. And we also have to pass a corner. Yeah, this is nonsense what I'm doing here. The reset is okay, this is nonsense. So I need a corner, the 0 corner result. Why am I making a copy of myself? Yeah, I don't know. Problem I have with this is that this is an inconsistent state. Passing more axis in this mask than the k-1 value. And then afterwards reset it, but still. Maybe eventually I might add an assert to this constructor that checks that the number of bits is correct. So it doesn't feel good to construct it like that. Just doesn't. So maybe just should not to use the reset then. Just work on this directly. So I want to reset something, so I do an AND with the inverse of the axis. I mean, why not? It compiles and it works. It compiles. And then the corner index also must be changed. You want exactly that axis to be set or unset. So the corner index is still a bit set. I don't have a set that takes 2 arguments. CornerIndex. Thought it was a bit set. No, it is a math kFaceIndex. kFaceIndex, yeah. And then finally it will stop compiling. Yeah, it was about time. I mean, I was hoping for that, as you still remember. Unless, no, wait a minute. This is not a bit set. I'm so confused. No. What? There is change. These things are now being initialized. Yeah, if they are correct. So, which direction do we have now? We have the in one-way direction, I think. Going from starting to lose it here. Let's concentrate on this for a bit. I want that to be private. It's only being called here. What the hell? The mother of desperately searching for agents.md, which don't exist, I think. You already got all of it, man. Those 58 lines there. Oh, what a sneaky bastard. List, read, search, read. Oh, I read I added a template trend. I'm reading it wrong. It didn't add anything, it just tells me how to do it. And I did not follow my instructions. It said try to compile a project. What the hell? int. Oh, okay. We'll do that then. That actually works. I tried a lot of things before. Nothing worked. I added it in the wrong place. I should add it before the point where it is needed from. For, I mean, so before the remove bits. Yeah, now what? What is next? Remove bits. I want to go from a kFaceIndex to a kFace. That is what I want to do. Does that not already exist? Not really, no. So we could add a constructor here that takes a kFaceIndex. Or yeah, it's the inverse of this thing, isn't it? No, it's not. Turn the kFace. That's this first part here, right? What? Doesn't make any sense. Why? What is this? It's the wrong output. Yeah. That's in transform. There's no print on. Okay. What? kFace. I thought it had a print on. I looked at it. It had a print on. No, so there's a print on. Oh, it's private? Oh, it's private. Oh, okay. Yeah. Yep, that worked. So here we see that of all the k-axes, which were the, well, 0, 1, 0, 1, 0, 1, it removes the first one from the k-axis and then sets the 0 corner to all zeros. Well, that's special. I think it is correct. I can't remember anymore what exactly the corner was of the that is the corner. Yeah, so it is 0, 1, 0, 1. So that's the only one that matches. And then 0, 1, 0 again. So that's why I don't think let's align these two. Nope, don't see it. The corner, this is just one corner, and the corners are, well, there are 8 corners, because K is 3. It's a cube. And the 8 corners have these coordinates, but then 0 or 1, where there's a 1 here. So the lowest one is with this also a 0. And then all the other corners. Now if you remove this k-axis, then this thing gets fixed at 0. So the 0 corner doesn't change, and that, well, this bit is still being reset. I don't get it. Yeah, the 0 error, 0 corners is wrong. Definitely wrong. all zeros isn't even a corner. At all. Yeah, time to stop. Too tired. Hmm. Yeah. Hmm. Ha ha. Huh? What the fuck am I doing? Oh shit, I didn't see the bloody bishop. this one. I can go here. Check again, I lose it. Yeah. Put the queen in front. Yeah, that loses too. Oh, he can't take it. He can't take it, not immediately. Oh shit. Yeah. Oh, it was fun. I'm stopping.